Alright, this is week 1, and this was day 1, Wednesday. And in this same recording, we will also talk about Friday, day 2, here in a little bit. Logins in the room, information data assurance, course overview, and we start talking about information system security. What students are working on for Friday. Chapter 1, research, where can they find other resources? So, let's take a look. We talked about the Internet of Things. We have a whole chapter on that. The basis of what we talk about and what we do is really focused around data. In fact, I just ordered a book today that talks about how we've gone from like manual labor to the Industrial Revolution, in which we had machines and the political influence on machines, and then we went to information, and then the root of information is data. Alright, so I like to think of data as being in different states. Either the data is stored like on a hard drive or some drive somewheres, and that could be local, right on your machine or your device or your phone, or it could be there's a lot of data stored in LANs. NIAC does a lot of that. H drive, N drive, D drive, they store all kinds of information locally on their servers within their own LAN. And then you can store it in a WAN, or very often called in the cloud. Even though the cloud analogy can be used actually for both of these. And there is an analogy that kind of stems in here called fog. And we talk about that later in networking. The next place that's key is the data can be in transit. Basically moving across some network. That network could be through a cloud, it could be through a local area network. You know, it could actually be from your phone or your laptop through the air to an access point. So it could be right in where you are. And then the last, processed. It's in memory. We have a processor. It's moving through the computer. You might say it's kind of like transit or kind of like stored, but it's a different spot. You think about where the data is. Stored somewheres, moving between two locations, or it's actually in the computer being processed, or in the computing device being processed. The book talks about, is there a threat on the data? How vulnerable are we? And what kind of risks do we want to take to manage that? We're going to talk more about that here in a minute. We did a little review of the Internet. We talked about these Tier 1 providers. The Internet actually comes from the word internetwork. And this is a transport layer between these networks. That makes sense? So Facebook isn't actually in the Internet. Neither is Google. It's not in the Internet. Or any wiki, or the other literally millions of sites. The internet just provides us communication between them. And these tier 1 providers allow communications through the internet without a cost, and then all the other providers, as that filters down, our ISP, tier 2, tier 3, or whatever, ICM, they pay for the bandwidth in and out of those tier 1 providers. For example, NIAC, we have 2 connections to the ICM, and we pay some cost for the bandwidth going in and out. Now, you don't have to go through the internet. You can have some corporation like Walmart connect to all their remote stores through some service provider. Now, it's those same companies, Verizon and so forth, or maybe locally Omnitel, CLTel, WT, Winnebago, whatever, telephone service up there. They can do the same thing. Okay? And they can connect into the large service providers, which can make this connection through the cloud. Or you can have one location and another location connected, but not literally going through the internet. The internet, the World Wide Web, uses the internet in order for it to send information. The internet, we can send email through the internet without using browsers. You could actually develop some type of chat if you want it through the internet without actually using the World Wide Web. For sure, you can do file transfer protocol through the internet, okay, without using browsers. Okay, we can use the internet to connect to local servers without using a browser, just using some piece of software. The World Wide Web, though, caused the World Wide Web development and being able to use the internet developed into an unbelievable way of communicating, and it grew so fast that security was not the primary thing people worried about in terms of the internet. And, you know, as the book says too, TCP IP wasn't built with security in mind. It was built for transporting traffic through a network. So, what things can we do? Well, we talked about that. We can have servers and access them. We can use HTML along with hypertext transfer protocol, or transfer securely, to move that HTML, and a piece of software called browsers that interpret that HTML. We can design that and then develop. We can use, use a different color here. So then we could use JavaScript, PHP to access SQL. And this grew extremely fast. This is kind of referred to sometimes as a full stack, in the sense of, let me show that. So we have all of these together, all these ideas together, in order to have a good experience of accessing data, retrieving data, and so forth via the World Wide Web. Okay. Now let me go back up here. That we got off on a tangent a little bit, but AT&T, American Telephone and American Telegraph and Telephone Company, became a monopoly around 1910, and then for all these years, approximately in 1984, they broke it up into 8 parts. It used to be called Ma Bell. Bell Labs developed tons of great software over the years. That was never proprietary. It was always open. But anyway, it split up to 8, and those 8 grew into what we have today: Verizon, AT&T, and Sprint came out of that, and so forth. And if you wonder, those go back to this whole idea of Tier 1 providers. We also talked about, is the internet an open or closed system? And you could argue both a little bit, but in most cases we tend to think of it as an open system. Pretty much anybody can hook into the internet. Now you have to go through an ISP, but they have some control, but there isn't a owner or a particular group that you have to see to when you go in, which makes it security an issue. Whereas a lot of proprietary software is more closed. You can't decompile it and look at it and so forth. Again, open, which makes it less secure in general. Alright, day 2. So this is still week 1, but now it's day 2. It's Friday. 2 other courses taught on Friday, but this is what we want to focus on. Alright, I'm still getting used to my busy schedule, but anyway, we continue to talk about information systems. We didn't get time to do a practice test. Access Net Labs students said they have done that. I haven't created any labs. Oh, and yeah, we had some treats. And we talked about the good work the network management students did on Thursday. And it's really appreciative, and I told them to make sure they're logging that and building their electronic portfolios. Alright, we talked about data centers. It's interesting. Companies have big decisions. You know, they traditionally companies had a lack of a better term, they use server farms. They had huge storage connected to racks of these servers that fit in racks, and huge storage area networks and so forth within their companies. Well, while they're finding, should they offload some of that to data centers? And I listed Light Edge only because we have toured Light Edge a few times, and I know Roger Millman still works there as far as I know. Okay? So then we have this concern between, you know, what do we keep locally and what do we move off to the cloud? You know, like the hospital, if I remember right, they built up a very nice data center out on the West Campus, I am told. They have a server farm, so they really have their own cloud there for various reasons, medically, you know, the concerns of storing it somewhere else. Alright. Next, I run through, it's a little different than how the book explains it, but let's go through this here again. So we, again, emphasizing data, moving, processed, stored, cloud and fog, locally, just talked about that. That's the asset that we think about most of the time in security, even though it isn't, okay, it's one. We have the securing the actual equipment, right? You can't have your servers all burn up, okay? So we have assets, but the one we seem to focus on more so is data, and we also will talk about securing the physical and hardening the equipment and so forth. But a lot of that all stems back to we can't afford to have the data changed, seen, destroyed. Okay? So, is there a threat to that? Sure. All kinds of threats to data, like I just mentioned. Is there some way to carry out the threat? Is there a threat agent? You know, what's the chances of a hurricane in Iowa? Low. What's the chances of a tornado in Iowa? Higher. Okay, so You have something that can carry out the threat. Now I'm talking about physical damage to the equipment that's holding the data. And of course we have the threats of hackers and all those things. Based on how you have your data stored, or how you're processing it, or how you're and where you're moving it, will affect whether there's a threat on it. And then you have to think about it. Can that threat occur? And what are the chances that that threat will occur? How vulnerable are you? What are the odds that somebody can hack into that? Okay? And it will vary. You might think, well, it's dangerous no matter where it is. Well, not necessarily. Okay? So what's the vulnerability? Once you figure that out, then you determine your risk level. Do you pass off the risk? Do you accept it? Or do you mitigate it? Okay, pass it off, get insurance, send the data to the cloud, let somebody else worry about it. Accept it and say, well, if this happens, it's going to cost us this much to recover, and it's going to cost us this much to avoid that from happening, and the chances of it happening, here, vulnerability, are very, very slim. You might just decide to accept the risk. Or you can mitigate it. You can do all kinds of measures to do that. Most people, it's some combination between all of these. Then you have to have a plan. If there's an exploit, something happens to the data, you've got to have a plan. And we learn about that here in this course. Security policies, incident planning, what do? First thing you do is you call your lawyer. Really, I think most plans do when they have a breach. First thing they do is get a hold of the legal team and say, okay, now what's going to happen? Okay. We talked a little bit about information systems, all the things that make this work. We actually spent a fair amount of time in class talking about this. All of the things people focusing, the network administrator, the database administrator, and so forth. They're all concerned about security, but it's not their main focus. Then you have information systems security, which focuses directly on the security. And then sometimes the trick, believe it or not, is doing a good job of working between these two. I've often heard people in the IT area say, well, there's so much security, our business can't actually do business. Okay, and then of course there's not enough security where as soon as there's a breach, you say, well, why wasn't that secured? Okay, so it's some type of balance. You can secure data if you never allow anybody to look at it or see it, lock it up in a safe, etc. Almost done. Last page, last slide. Term used from the text, tenets. I like it. Okay. Key things: confidentiality. Who can see what? We can manage that using cryptography. Integrity. Is the data accurate? Okay. Can we trust the data? Can we trust the data? And then, most situations, the data has to be made available to certain people. So let's talk a little bit about all three of those. Okay? Who can see it? A lot of that rests right down here. Authenticate somebody in, authorize, give them permission, and then manage them. Keep track and audit what they do and where they go and what they do. All of this can be done nowadays. We have a great ability to store and keep track of huge amounts of data and lots of ways to authenticate people and so forth. All right. Integrity can be done with hashing. You can take the information and hash it into a set block using something like an MD5 half or SHA. And we get this set block. And then the next time you look at the data, you hash it again and compare those two set blocks. If they're identical, there's a really good chance the data is still accurate. If they're not, something happened to the data. Okay? You think of this a lot when people download information. It gets checked to make sure that it got downloaded correctly. When we're trying to The key thing on availability is we have to make data available. People in the hospital that are treating a patient have to be able to see their records. All of them. I mean, you can't say, well, I think we'll just tell you some of it. No, they have to be able to see it all. So we have to figure in, of course we do in all of this, human factor of managing all those. The human factor in authentication, the human factor in making it available, and people knowing the information, and how do we manage the humans not to share that information, and so forth. Alright, two more things. Cryptography is a broad field, it's been around since Julius Caesar. Okay. Encryption with some algorithm and a key is popular nowadays. Ciphertext is text that's encrypted. Clear text is text that's not encrypted. And there's all kinds of rules, both in the United States and between different countries of what you can encrypt and how you move that around. And we'll talk about that as the year goes on. Hashing, we talked about that. You hash a message on one end, message gets sent, hash gets sent, hash it again on the other end, see if it matches. You can also use this for a digital signature, which will be one of the fun things we talk about this coming week. Sorry it was so long. Sort of sorry, not real sorry. Okay, that is it for me for the first week. Great, all done.